When a question asks you to find the average rate of change, typically that's just code for find the slope. So in this case, we have the age of a person, and we have the maximum number of heartbeats, which represents our Y value. And we're going to answer all of these questions for this table, and we're trying to find the average rate of change, which is really just code for find the slope for each of those intervals. So let's take a look at that first question. The first question says, plot the ordered pairs on a graph and connect it with a straight line, or with straight lines. So here are the points, and as you can see, I'm connecting it with a line. So it looks pretty straight, but it's kind of hard to tell because I don't have those grid lines. So we're going to move on to the next question. And this question asks us to compute the average rate of change in the maximum number of heartbeats between 30 and 40 years of age. So on my table, I'm looking at this ordered pair and this ordered pair. Now I'm going to do this just like normal. I'm going to use my slope formula, which is second y minus first y over second x minus first x. And notice I get an average rate of change of -1/2 or -0.5. So quite often when we're dealing with rate of change, we turn them into decimals. I'm going to do the same thing for my part C, between 60 and 70. So now I'm between this ordered pair and this ordered pair. And notice what I'm doing. Same thing, average rate of change. I end up with -1/2 or -0.5. So now the question says, based on your results, so based on our visual results in the graph, based on the fact that we found the average rate of change between two different intervals, do we think that the maximum number of heartbeats is linearly related to age? Meaning, does it make a nice straight line and why? So I would say yes, because the average rate of change appears to be constant. So it seems like for every additional 10 years, the maximum number of heartbeats is decreasing by 5. So that's when we're using that interpretation of slope. So for every 2 years, it's decreasing by 1 beat per minute, or for every 10 years in age, it's decreasing by 5 beats per minute. And now we're going to interpret the slope, and again, we're going to interpret for every additional 2 years, the maximum number of heartbeats decreases by 1 beat per minute, and like I just said, 1 year decreases by 0.5, or for every 10 years, it decreases by 5. So go ahead and try this question and then interpret your results. So Kevin's savings account balance changed from $1,150 in January, so I'm going to call that in month 1, Kevin had $1,150, to $1,450 in April. So month 4, he had $1,450. We're going to use this to find the average rate of change. Before I do this, let's talk about why I put 1 instead of $1,150 first. Because we know that the balance depends on what month it is. So we always put the independent variable as that first ordered part of our ordered pair and the dependent as our second. So as time changes, the balance changes. So the balance depends on time. Now, digress, moving forward to slope. Find the slope by 1450 minus 1150 over 4 minus 1. So 1450 minus 1150 is $300. 4 minus 1 is 3. I get my slope of 100, or 100 over 1. So that is my slope. Put it over 1 if it makes you feel better. Again, if you're going to explain the rate of change in the context of the question, it's not a bad idea to put the label on there. So this was dollars and this was months. So to explain the rate of change, I would say for every additional month, Kevin's savings account balance increases by $100. So that's interpreting the 100 over 1.